and welcome. I am Dr. Pauline Fu. In this video, I will continue with compound interest. Topic include calculate term N, calculate interest I, and calculate equivalent dates. By the end of this lecture, you would be able to determine number of conversion periods and solve equivalent dates, compute periodic and nominal interest rate, compute effective and equivalent rate of interest. How do we determine term N? Remember, we have formula, future value equal to present value, 1 plus I raised to power N. We rearrange this equation a little bit and we can solve for N. So both sides, we divide by present value. So we move present value on left-hand side so that right-hand side, so both sides, let me put this way, both sides divide by PV, and PV canceled out. Left-hand side, you have FV over PV. Right-hand side, you have 1 plus I raised to power N. And then you take a logarithm on both sides of the equation. So take ln ln, natural logarithm, okay? And now you can move this N in front of ln. This is one of the property of a logarithm, okay? So this is the exponent, move this N in front of ln so that you have equal to N times ln 1 plus I. This is right-hand side. Left-hand side still have FV over PV, take ln. And now you can solve for N. Both sides you divide, move this over to the left-hand side. So you get the ln N formula here. So based on future value, present value, and periodic interest I, you can solve for N algebraically. Let's look at this example. Suppose future value 1600, present value 1000, and suppose interest rate is 5% compounded quarterly. 5% compounded quarterly. So that means the periodic rate is 5% divided by 4. Okay, 1.25% every quarter. So once you have these three numbers, present value, future value, periodic rate I, you plug into this formula. And you can get this number. Okay. If you want to use, how do you do the calculation on ln? You can do this. I'm going to quit. ln log is here. Okay. So what you do on the top first, you do 1600 divided by 1000, that is 1.6. So you do 1.6 ln, you get 0.47. Okay. So you can store this number in number one position. Then you clear, do the next logarithm. So 1.0125, 1.0125. This number take long, ln. You get this number, and store this number in number two. Now you recall number one. Okay, this number divide. Recall number two. Divide this number equal. So this is the result, 37.83. And make sure the unit for this result is quarters. The unit is quarters. If the question asks you how many years, you have to know 1 year has 4 quarters. Okay, so to convert this to years, this number divided by 4. Okay, so this number divide 4. You get how many years? So it is 9.45 years. 9.45 years. Okay. If you want to know 9.45 years, exactly how many years, how many months, obviously it is 9 years, and then 0.4587 years. So maybe you convert this decimal part into the months. You do this. So minus 9 to get decimal part, and then multiply 12 to get months. So 5.5 months, roughly 6 months, 5.5 months. So final answer, 9 years and 5.5 months. Okay, so this is this question. If you want to convert this quarter into months, you multiply by 3. Multiply by 3, you get the unit is in months. So now let's calculating the equated date by doing an example. A payment of 500 is due today, 1,000 due in 1 year. Another payment, 3,000, is due in 5 years. Determine the date at which a single payment of 5,000 will settle the date if interest is compounded, is 4% compounded annually. Okay, interest compounded annually. So initially you have 3 payments. Now you want to make 1 single payment. So what is the date for that 1 single payment? That is the question. Okay. So let's draw a time diagram to illustrate. So a payment is due today, 500. So this is today. A payment is due today, 500. 1,000 due in 1 year, 5,000 due in 5,000, 3,000 is due. Okay. So first step, we need to calculate what is the equivalent value. Oops, sorry. What is the equivalent value? At this point for all these 3 payments. So in other words, we need to figure out what is the present value for 1,000 relative to this point today. What is the present value for 3,000 relative to today? And then we add these 3 numbers together. Add these 3 numbers together. That is our present value. And then we have future value, 5,000. So we want to calculate the term N, how long. Okay. So go back to how do we calculate the present value for this $1,000? So you just use the formula, PV equal to FV times 1 plus I raised to power N. So what is the present dollar for 1,000? It is this amount. I is 4% or 0.04. Oh, PV, this is negative N because, okay. So N equal to 1 from today to 1 year. Similarly, you calculate present value for this 3,000. So use this formula, plug in. Okay. And add all these three numbers together, you get the present value is $3,927. Once you have this number, and you also have a future value, 5,000, the question is, what is the term N? That is the question. Okay, and we can plug in term N formula. Okay, ln FV over PV over ln 1 plus I, and you get this yes or this month. So now I want to show you the calculator method. Okay, calculator method. For this question here, if you know the present value and future value, how do you use calculator here? I'm going to second quit. First, interest is compounded annually, so set PY equal to 1, CY equal to 1. So second, PY 1, enter. Down arrow key, CY is 1. Now enter 3,927.319,782. This is the present value. Okay. This is the present. Oops. No, that is not. That is CY. CY should be equal to 1. Enter. I should put second quit. Okay, so double check. Second PY is 1. CY is 1, correct. And now I enter the present value. By the way, when you have a present value and a future value at the same time, when you enter the calculator, one of them entered as a negative number. Okay, so let's enter 3,927.319,782. So this number is negative PV. When you have a PV, FV appeared, both showed up on calculator. One of them must enter negative. Okay, so this is PV. Now 5,000 is FV. So 0 is a PMT. 4 is interest. IY, compute, term N. Okay, so you get this one. 6.15 unit is years. Multiply this number by 12, you get how many months? So 73.88 months. Okay, so this is a calculator method, Excel. For Excel, to calculate term N, you use NPER, is the function for term N. Rate is 4% compounded annually. PMT 0. PV negative. In Excel, when you need to enter both PV and FV, one of them entered as a negative number. So negative 3,927, 319,782. So this is the present value. Future value 5,000. Press enter. So you get 6.16. I need to increase decimal places. Change the format. because this is rate, I want to eliminate the dollar sign. It's weird. So I just change to number. And then more decimal places. I click OK button. So this is agree with this number. Okay. So you can see the formula here. This is the formula I entered. Okay. All right. So this is a term N. Next, how do we solve for periodic rate I? Again, we can solve for I from this formula. Okay. Starting from this formula. We want to solve for I, both sides, we raise power in this equation. This is an equation. Both sides I raise to power 1 over n. So raise to power 1 over n. On left hand side, raise to power 1 over n. On right hand side, and then this n and 1 over n cancelled out. Okay, you only have right hand side, you only have PV times 1 plus I. On the left hand side, you have FV. No, I have to redo it. So the very first step is to move this PV to another side, to left hand side. So you have FV over PV equal to 1 plus I raised to power n. And now both equation you raise to power 1 over n. And this one you raise to power 1 over n. Okay. And then this n and 1 over n cancelled out. You only have 1 plus I left on the right hand side. Left hand side, you have FV over PV raised to power 1 over n. 1 over n. Now move this one to left hand side. Right hand side, you have I. So this is your formula. Okay. So when you know future value, present value, you can use this formula to solve for periodic rate I. Example, calculate the nominal rate of interest compounded semi-annually if 3,000 accumulates to $5,201 in 8 years. So 3,000 is present value. 5,201 is future value. In 8 years, n equal to 8 times 2. Why multiply 2? Because compounded annually, semi-annually, n equal to 16. So 16 years, not 16 years, 16 half years. Okay. So we have these three numbers, PV, FV, N, and then plug in the formula here. Okay. And we can solve for I. I equal to FV over PV raised to power 1 over n, and then minus 1. Okay. Plug in the numbers. So it is I'm just going to use calculator to show you, okay? So FV, the second quit, $5,201.96. This one divided 3,000 equal to this number. This number raised to power. So YX is raised to power. Raised to power bracket 1 over n means 1 divided by 16 closing bracket equal. And this number minus 1 equal. So that is interest, 0.035. Okay. 0.035. And this rate is a periodic rate, means every half year the rate is this. The question asks you nominal rate means what is the rate for 1 year? So you have to change to use this I, nominal rate, calculator will use IY. Okay, so equal to 0.035 times 2, get nominal rate. The answer is 0.07. Okay, or 7%. So this use formula. There is a function in calculator, directly calculate interest rate. Okay, so let's do it. Interest rate is compounded semi-annually, so we need to set up PY equal to 2, and CY is 2, second equate, and then 3,000 negative number PV, and then $5,201.96. This number is FV. Remember, when you have both present value and future value, one of them will enter as negative number. Okay. 0 PMT, 16 is a term N, compute, IY. See, the calculator directly give you nominal rate, okay, 7%. So this one, I already did it. The next, introduce new terminology, equivalent rate and effective rate. So what is the equivalent rate? Interest rate that increase a given principal to the same future value over the same period of time are called equivalent rates. For example, 9.381% per annum compounded annually and 9% per annum compounded monthly. Those are equivalent rates. Why? Consider $1. If you have $1 and you use 9.381% compounded annually, what would it be in 1 year? That $1 will become $1 how much? Okay, will become how much? And then you calculate $1 if the interest is 9% compounded monthly. What is the future value of this $1? Okay, if the future value under both situations is equal, these are the equivalent rates. So let's verify. Okay. Let's verify future value of this $1. So first, calculate what is the future value if interest is 9.381 compounded annually. Okay, because it is compounded annually, so we need to set PY equal to 1, and CY is, I haven't, second, PY is 1, enter. Down arrow, okay, CY is 1, so second quit. Okay. So now I will enter $1 as present value. 1 is the present value. Okay. Interest is 9.381. That is the interest, IY. It is 1 year. So 1 is a term N. Do not forget 0 is PMT. Now compute FV. So future value $1.09. Okay, $1.09. Under this situation, I get future value for $1. Okay, this is the future value under this condition. Now, I will do, how about if interest is 9% compounded monthly, what would be $1 in 1 year? So second quit, because it's compounded monthly, PY equal to 12, second PY, no. Second PY 12, enter. Down arrow, okay, CY is 12, second quit. Now enter $1 as present value. 0 is PMT. 1 year has 12 months, so 12 is N. Why? Because it is compounded monthly. Okay. And then we compute 9 is interest, 9 is IY, it is given here, 9. So compute FV. See, exactly the same number as we get here. That's why those two rates are equivalent rates. They give the same amount of future value based on the same principle. And this annually compounded rate is called effective rate of interest. So effective rate of interest, F, there's a formula. It is 1 plus I. This means raised to power M. I will rewrite it. Equivalent rate of interest equal to 1 plus periodic rate raised to power M. M represent compounding period, number of compounding period per year. So let's do an example. Determine the effective rate of interest corresponding to 6% per annum. There are 4 situations if it is compounded annually. So compounded annually means M equal to 1, M equal to 1, and we plug in the formula. So F equal to 1 plus 6% compounded annually, then raised to power 1. Okay. So it is equal to effective rate. Oh, there is a, sorry, there is a missed, have to minus 1. Okay, there's a typo here, minus 1. Okay. So this one minus 1 equal to 6%. Now situation 2, compounded semi-annually. Semi-annually means M equal to 2. So equivalent rate of interest F equal to 1 plus I is 6%, compounded semi-annually, divided by 2. And then raised to power 2 minus 1. Okay. So this number, I'm going to use Excel to quickly figure it out. So 1 plus 6% divided by 2 raised to power 2 minus 1. I have to start with equal sign. So it is 6.09%. So situation 3, quarterly. Quarterly means M equal to 4. So F equal to 1 plus I is 6% divided by 4, because it is compounded quarterly, and then raised to power 4 minus 1. Okay, so what is this number? So equal to 1 plus 6%, 1 plus 6% divided by 4 raised to power 4 minus 1. So it is 6%. Maybe I will try to increase decimal place, change the format of this cell. So it should be number, 2 decimal place, maybe 4 decimal place. So this is 6.14%. Last situation, if interest is compounded monthly, means M equal to 12. So equivalent rate of interest F equal to 1 plus 6% divided by 12, and then raised to power 12 minus 1. Okay. So this equal to 1 plus 6% divided by 12 raised to power 12 minus 1. Okay, I'm going to format this cell. Number 4 decimal place. So 6.17%. Okay, so we calculated effective rate of interest based on different situations. Now, equivalent rate, what nominal annual rate compounded quarterly is equivalent to 7.5% compounded monthly. Okay. What nominal rate compounded quarterly equivalent to 7.5% compounded monthly. So consider this one here. Remember future value equal to 1 plus I raised to power n. There's a PV here, present value PV times 1 plus I raised to power n. Because they are equivalent means they are going to achieve the same future value. So let's suppose present value equal to 1. Just suppose. If present value is 1, future value becomes 1 plus I raised to power n. Okay. Now, under this situation, what nominal rate compounded quarterly? So suppose it is X%. compounded quarterly means divided by 4. And we have 1 plus, so 1 plus, and then raised to power n. Suppose this is in 1 year, so compounded quarterly, so raised to power 4. Equivalent means equal. 7.5% compounded monthly equal 1 plus 7.5%. Compounded monthly means divide by 12 and then raised to power 12. So here we have one equation, one unknown. We can solve for this x. Okay, so how do I solve it? I will do right hand side. So right hand side equal to, maybe I will move this. Right hand side 1 plus 7.5% over 12 raised to power 12. This is right hand side. Okay, and this number, so this equal to this number equal to, and then 1 plus x% over 4 equal to this number raised to power 1 over 4. Both sides, I take power 1 over 4. Okay, so this number I need to raise to power 1 over 4. Okay. I get this number. And this number minus 1, you get x% divide 4 equal to this number minus 1. So it becomes 0.0189. So finally, x equal to this number multiply 4. So x% equal to this number multiplied by 4. So first, this number minus 1, then this multiply 4. Okay, again, our format this one to get format cells. So 4 decimal places. So x% equal to 0.0755. So x equal to 7.55. So this is an algebraic. I do a little bit algebraic. I get the answer. Okay. The answer here have more decimal place. If I increase my decimal place, it is agree with this number here. Okay, maybe I will increase decimal place. 4 month cells instead of 4, maybe 6. Okay, so I increase decimal place, it gets the same number here. 47547. Okay. 47. So this is a calculate the equivalent rate. Okay. Now, is there a calculator method? Yes. So for calculator method, you have to do this. You need to practice more, okay, for this one. So I do second quit, clear any previous entries. And now your starting point is the second, this button here, okay. Second, then click number 2 button. And after that, you have nominal rate type in the one you already know, 7.5. 7.5. Okay. Enter. Okay. And then go, not this one, so I messed up. Second. Where's my calculator? ICONV, yes, just double check. So I'll redo it. So clear everything, second, clear. So second and quick ICONV, this button here, ICONV. And then you have a nominal rate, type in 7.5 and press enter. Okay, now use this up arrow key, CY, so 7.5 compounded monthly, you type in 12, enter. Okay, up arrow again, you have a effective rate, press CPT compute. Okay, and then click down arrow key. This time, you can ask CY refer to compounded quarterly. Compounded quarterly, this CY is 4. So enter. Down arrow key again, you have nominal rate and press CPT compute. See, you get this number, 7.547. Okay, so again, you need to practice more for this calculator method. Okay. All right. So, question, this one here. What is the effective annual rate of interest if $100 grows to $150 in 6 years, compounded quarterly? Okay, so for this question, I can use a different method. First, I will use formula. So I equal to FV, future value, over PV, and then raised to power 1 over n minus 1. So this is the formula. Okay. So $100 is PV. 150 is FV. In 6 years, compounded quarterly. So n equal to 6 years times 4, because 1 year has 4 quarters. So n equal to 24. Plug in these 3 numbers into this formula. So I will use Excel to do it. Not block your content. So equal bracket FV 150 over 100 raised to power 1 over n, n is 24, and then minus 1. Okay, so this is my Excel. 150. And the Excel calculate this one, and this I is just periodic rate. You have to use this one times 4 to get, the question asks you effective annual rate. So this number have to times 4, oops, times 4 to get annual rate. So 6.82%. If I increase decimal place, you will see the answer I put in. So 6.815%. Okay, so I will copy down here. This give you I. Remember, I refer to periodic rate. The question asks you annual rate. Okay, So I calculate 0.0170, 0.017. So annual rate, you have to use 0.017 multiply 4. And again, you get 6.815%. So this is the formula method. Similarly, you can use Excel, not Excel, the calculator. Okay, calculator. So I will clear everything. It is compounded totally, so we need to set up PY equal to 4. Enter. Down arrow key, CY is 4. Second, quit. Now enter 100 as a negative number for present value. And 150 is future value. When you have both present value and future value, you need to enter one of them as a negative number. Okay? And then 24 is a term N 0 PMT compute IY. So the calculator directly gives you annual rate 6.8152. Okay. So this is and calculator method. So do we have a Excel method to calculate rate? Yes, we do. The formula is rate equal RATE rate, and then NPER term N 24, term N, PMT 0, PV negative 100, FV 100, FV 150, and you get this 0.017. The result from Excel usually refer to periodic rate. Okay? So you have to calculate annual rate, periodic rate times 4, because compounded quarterly. So you get this rate. If you change to percentage, it is this number. Okay? So I'm going to just want to copy this. Rate, and this one you get 0.017. Then return here times 4, you get the answer. Okay. All right. So last example, found nominal annual rate of interest compounded quarterly, that is equal to an effective rate of 9.25%. Okay. So how do we solve this question? So again, we can solve it algebraically. Okay. So found the nominal rate. Okay. I don't know. I use X represent the nominal rate. X, okay. X percent is my nominal rate. X percent, and then 1 plus X percent. This compounded quarterly divided by 4, raised to power 4. Okay, raised to power 4 should be equal to 9.25%. Okay, and this one compound effective, because this is effective rate, means compounded annually. Okay, and the percent. So should be divided by 1, and then raised to power 1. Raised to power 1. Okay. When you divide something divided by 1, it is the same as this number itself. So I will omit this one. Okay. So one equation, one unknown, you can solve for this x. Okay, so I'm going to use Excel to solve for this x. Right hand side equal to 1 plus 9.25%. This is my right hand side. And this right hand side raised to power 1 over 4. Okay, equal to this one raised to power 1 over 4. You get 1 plus x divided by 4. And then this number minus 1. And then the number you get, this one, times 4, you get x. Okay, so x is 8.945%. This is algebraically you solve for this one. And then you can use calculator to do it. Okay, so second, quit. For calculator, you start with second, then press this button, ICONV. Not this one. So second, ICONV. It is number 2 button. So second, number 2. And you have NOM. So the given rate is 9.25. You type in 9.25. Enter. Then use up arrow key, CY. This one is compounded annually, so CY equal to 1. Enter. Up arrow key, effect. And then you click compute. After that, click down arrow key, CY. For this one, compounded quarterly, so CY equal to 4. Enter. Down arrow key. You get nominal rate, compute, you get the rate. See, 8.945. Okay. All right. In summary, this lecture calculates periodic rate I, nominal rate. It also calculates term N as well as the equivalent dates. Thank you so much for your time. I look forward to see you next time.